Congratulations on being 100% in attendance today. That is exciting. Okay. I'll give you like 30 more seconds to get ready for notes, getting your notebook out, kind of preparing. You can kind of see how much we're going to have to take in terms of notes today, so you can plan your paper usage accordingly. You are welcome to reference your old notes. However, I think it's going to be most beneficial to you to rewrite them, even if you have easy access to your old notes. It's good practice to write them again. It'll help solidify these concepts in your brain. How did last night's thing go? Worksheets? Good. Well, that's good. I mean, it was so hard when we did it the first time around, but you guys are so much smarter now. Do your brains feel bigger?
Oh, yeah.
Do your heads feel a little fuller?
Yeah.
They look a little fuller. Apologize to your neighbor in case they overfill and you squirt brain smarts out your ears. That'd be awkward. All right. All right, ladies and gentlemen, today we're going to be starting with section 8.3, logs. Logarithms. Are you ready? Nod your head if you're ready. You may focus your silent attention this way. And here we go. So our logarithmic notation looks something like this. Y equals log, whoa, that's a weird looking letter, log base A of X. And let's label all the parts of this thing. So this thing right here, do you see this L-O-G? Yes. What does that spell? Log, yes, ooh, good spelling, ladies and gentlemen. And that itself is the log function. What is that L-O-G, ladies and gentlemen? Log. The log function. And do you see this little A? Yes. Yes, this little A is called the base. What is that little A right there called, ladies and gentlemen? The base. And this, whatever comes after the base is called the argument. What comes after the base, ladies and gentlemen? Argument. The argument. All right, fantastic. And our first step in dealing with logs, because logs are kind of useful, they are kind of not useful at all on their own, but it's useful if we translate them to exponential. So let's just jump right in there. Y equals log base A of X can be converted to an exponential that looks something like this. X equals A to the Y. Go ahead and say, oh. Oh, that was totally fake. Come on, you can pretend to be more excited. There we go. That's what I'm looking for. All right. I appreciate the less fake enthusiasm. All right, so let's take a look here. There's a couple key things that we need to remember translating back and forth with logs. And the first is the base is always the base. So what are we going to remember, ladies and gentlemen?
The base is always.
All right, notice how in both the log and the exponential, the base is A. So remember, the first thing is the base is always the base. So what's the first thing we need to remember when translating between logs and exponentials, ladies and gentlemen?
Base is always the base.
Good memory. Now here with the log, the constant, the number by itself, becomes the exponent. So one more time. The number by itself becomes the exponent. The number by itself becomes what, ladies and gentlemen? The exponent. All right, fantastic. And the argument becomes the number by itself. What happens to the argument, ladies and gentlemen?
Becomes the number by itself.
Yeah, that one was a little convoluted. I won't make you say that again. But let's practice converting back and forth. So first we're going to start with a log and convert to an exponential, and then we're going to have an exponential convert to a log, and then you'll get to practice a few on your own. Nod your head if you're ready. Not too hard. You got all those smarts in there. You don't want them to fall out. Jeez, chill. Okay. Oh, geez. All right, here we go. Our first example. What are we doing? Logs to exponentials? Sure. All right. Y equals log base 3 of 81. All right. Your first challenge. Let's convert this to an exponential. The first thing you need to remember is the base is always the base. What's the first thing you need to remember, ladies and gentlemen? All right. What is the base on this log function, ladies and gentlemen? 3. All right, and then the exponent is the number by itself. What's the exponent going to be in this particular problem, ladies and gentlemen? 1. Yes, good answer. It was a toughly worded question. You got it, and it equals the argument. So what does it equal, ladies and gentlemen? 81. Fantastic. Go ahead and say, yeah. All right, let's try one more of these. You guys are champions. Let's see. Give me your favorite letter, Emily. You can't pick E because that's going to be confusing, sorry.
M.
There we go. M or N?
M.
M?
M.
Okay.
E-M.
Oh, smart. I got you. M equals log base. Give me a number, Christina, between 1 and 9.
6.
6. You got it. And give me another number between 1 and 100, Gianni.
What?
Give me a number between 1 and 100. 21. All right. You all right there, Rowan? Am I out of tissues again? Been running out all day. Okay, nice. So we've got this log. We need to convert it to an exponential. And remember, the base is always the base. What do you need to remember first, ladies and gentlemen? All right, so what's the base in this particular problem, ladies and gentlemen? 6. You got it. And it nope, sorry. I need an exponential. What's the exponent going to be here, smart children? M. And what does it equal? 20. All right, you are pretty much experts now at converting from logs to exponentials. Let's see if we can go back. What's up, Monica?
Can we solve it if we can? Like the
Not quite yet.
Okay.
Yes, eventually, but pretend right now that you don't know how to solve it. Can you pretend? Okay, excellent pretending. All right, let's try the opposite way. So let's start with an exponential and convert to a log. Here we go. I'm just going to give you the 2 examples. I'll let you try them on your own. We'll confirm your smartness, and then I'll let you confirm your smartness for a few more minutes, and then we'll go on to our next section. Sound good? All right. 5 to the 4 equals B. Z to the 1.2 equals 7. Convert. Ready, go.
What? Is that 5?
Yes.
Are you supposed to solve the x part?
You're just supposed to convert it to a log.
Come on, John.
Convert it to a log. Remember, the base is always the base. We're just going backwards from the first examples. Perhaps we should do the first one together. Your questions tell me that we should. All right, I know the base is always the base. So I'm going to have log. And what's the base over here, ladies and gentlemen? 5. Good. And the argument will be B, and it equals 4. Nod your head if you got that one already. Ooh, nice. Quick mathematicians. Cam raises his hand in feeble enthusiasm instead of nodding your head. I appreciate you. Now let's try the next one. Let's read. Give me a thumbs up if you're ready for the second one. Okay, I see some people still writing, so I'll wait. And it'll sound so cool when we all say it all together, exactly perfect. Oh, I'm so looking forward to this. Ready? Are you ready? Okay, so it's going to sound like log base blah equals blah, but you're going to fill in the blahs with the things, yes? Okay, ready, go.
Log base D equals D.
Log base blah of blah equals blah. Let's try it again. Ready, go.
Log base D equals 7 equals 1.2.
Excellent job mumbling together, ladies and gentlemen. Okay, so here's what we're going to do. I'm going to hand out your worksheet for tonight. I'm going to give you like 2 minutes, just 2 minutes to work on the first section. It's okay if you don't finish. There'll be lots of time at the end to go back, but I just want, while it's fresh in your mind, for you to practice this a couple more times, really solidify it in there, and then we'll move on to section 8.4. You ready? Okay, here we go. 2 minutes. As soon as you get your paper, it's going to be best if you work efficiently. So you're going to work on problems 1 through 8. Which problems, ladies and gentlemen? Which problems, ladies and gentlemen?
1 through 8.
Okay. All right, work silently, independently, and efficiently. And we'll stop in about 94 seconds now.
Hurry up, please.
Are the little apples making you hungry?
Chill, broski. Chill. Thank you, miss.
Okay, all right, you got like 80 seconds now.
Carl.
All right, folks, let's stay focused on our own papers for the next 72 seconds. This is a great working volume. Let's keep it right here for 57 more seconds. Keep going for these ones. Oh, shoot. Yeah, keep going for these ones. 30 more seconds. Ooh, I see so many people already finished. Man, you guys are smart. Quick mathematicians. Go ahead and finish the last problem you're working on. Put your pencil down, stand up, push in your chair, stand behind your chair. Quick little mini brain break to transition back to taking notes. Here we go. You may focus your attention this way. I'm not going to explain it to you. We're just going to do it. You ready? You guys have done this one before, so you can handle it. Ready? 7, 6, 5, 4, 3, 2, 1. 7, 6, 5, 4, 3, 2, 1. 7, 6, 5, 4, 3, 2, 1. 7, 6, 5, 4, 3, 2, 1. Ready? 6, 5, 4, 3, 2, 1. 6, 5, 4, 3, 2, 1. 6, 5, 4, 3, 2, 1. 6, 5, 4, 3, 2, 1. 5, 4, 3, 2, 1. 5, 4, 3, 2, 1. 5, 4, 3, 2, 1. 5, 4, 3, 2, 1. 4, 3, 2, 1. 4, 3, 2, 1. 4, 3, 2, 1. 4, 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 2, 1. 2, 1. 2, 1. 2, 1. 2, 1. 1, 1, 1, 1. Yay! All right, have a seat. Get ready for notes. All right, ladies and gentlemen, moving on to the product rule and the quotient rule for logarithms. You recall a couple days ago we saw the product rule and the quotient rule for exponents. Nod your head if you at least remember those words. Okay, good. I see most of us nodding our heads. So you recall that the product and quotient rule for exponents included, so if we are multiplying exponents with the same base, what do we do with those exponents, ladies and gentlemen? Think about it. What do we do with those exponents, ladies and gentlemen? Add them. You got it. And if we're dividing exponentials with the same base, what do we do with those exponents? Subtract them. So it really shouldn't be a surprise that we see that there is a relationship between logs and exponentials, so it shouldn't be a surprise to see similar properties when we get to the product and quotient rule. So let's take a look. If we have the product rule, log base A of m times n, we can split it into two different logs. Log base A of m plus log base A of n. Look, I made it fit. Good job, me.
Nice.
Whoa. All right. And the quotient rule should not be surprising if we have log base B of, I don't know, what letter should we use? M over n. Whoops. You started yelling at me and I got all confused. M over n log base B of m minus log base B of n. Go ahead and look at these and say, ah, like you were totally expecting it. Whoa, you okay, Luis? All right. Okay, so we're going to use these properties to both expand logarithms and contract logarithms. So what we need to notice is that this equal sign kind of means that if we start with something that looks like this, we can expand to something like this. If we start with something that looks like this, we can expand it looks to something like this. Oh, I need to add one more rule. Oh my goodness. Oh dear. That's right. That is the rule that I need to add. Where should I add it, Luis?
At the bottom.
Okay, good idea. But I don't want to ruin Bodhi's nice note. He wrote you a nice note. It was a B and then some scribbles because he got tired of writing his name. He also drew you a happy face. Isn't it lovely?
Everything.
Say it again.
Has a goatee and everything.
Yeah, right? Well, I'm not quite sure, like, is that a nose? Is that the mouth? I don't know, but he was very proud of it, so I've left it all day. He was all excited this morning. He goes, can we help the big kids? Can I help the big kids? And I was like, yes, you can draw them a picture. It was, I don't know what, he is very helpful. So if you see him, say, thanks, bro, thanks for the picture. And
The other day I told
All right.
you that Terry Tower. You're gonna be in high school.
what? I hope not. If you're in high school for the next 11 years, oh man, that's not good. All right, Luis, what was the rule that you wanted?
The power rule.
The power rule.
My kids are gonna be in high school.
Could be. Okay, so here we go with the power rule. If we have log base A of m to the n, that exponent becomes a coefficient. So n log base A of m. Oops, sorry, equals. Go ahead and say, ah. Oh, there we go. Oh, you guys okay? Did you sneeze? Because it's tight? I don't know. Okay, so let's give these a couple tries. First, we're going to do a couple expansion problems. So I'll write it up here, and then we'll talk about which rules we need to use, and then we will use them. Our first expand looks something like this. Log. Whoa, goodness. Oh, goodness. Log base 2 of 6z. Let's give that a try. Examples. I'm so much taller in my head. I suppose I could scoot the boards down like 3 inches, but then you wouldn't be able to see the bottom of them. So I'll just have to suffer for your benefit. You're welcome. You're welcome. All right, so let's take a look here. It looks like we need to expand this logarithm. Are we going to use the product rule or the quotient rule, ladies and gentlemen? Yeah, how'd you know that? I heard you saying product rule. Gianni, how'd you know we were going to use the product rule? What operation is going on inside the argument?
I didn't say it.
Oh, okay, but you know. So what operation is going on between the 6 and the z in the argument here? Yes, sir, and multiplication means we need to use the product rule. Multiplication means we need to use which rule, ladies and gentlemen? Yes, and so we're going to split these logs up using what operation when we use the product rule? We split them up using what operation? Take a look. Addition! One more time. I heard a bunch of different words, so let's make sure we all know what's going on and say the same word together. Wait for it. If we're using that is a z. If we're using the product rule for expansion, we're going to split these logs up using what operation? Everybody? Addition. Very well said. That was a very nice tone of voice. You didn't yell at me, but I could still hear you all. That was just lovely. Okay, so here we go. It's going to look like log base 2 of 6 plus log base 2 of z. Well, that was easy. Not so bad. Let's try a more complicated one. Ooh. Okay. We're going to go from very simple to slightly more complicated. Did you guys have a joke? I love jokes.
Really?
Yeah.
New Year's.
Oh my God.
I missed it. I guess it was funny. Ha ha ha.
Why do golfers wear 2 pants?
What?
In case they get a hole in one. Dig it. Ha ha. Okay. All right. Log of 100x over root y. Oh, look at this and go ahead and say OMG. All right, so we went from just using the product rule once, and now we're going to have to use a bunch of different things. We're going to have to put all of our knowledge together. So clear your throat, sit up straight, like shake all the cobwebs out of your brain, because we're going to need to put all the pieces together. Are you guys ready? Yeah. Okay. So let's take a look at this. It looks like first, I think we should use the quotient rule. I see the 100x over the square root of y. I'm going to use the quotient rule first. If we're using the quotient rule, we separate the logs using what operation? Think about it. Everybody. Subtraction. Yes, very correct. So let's separate these using subtraction. I'm just going to stick with the black marker because it's working. Here we go. Log. Hey, wait. Notice something here. Do you see an explicitly written base on this log?
Yeah.
Well, it's invisible. You're close. Yes, it is a 10. Excellent. So great memory, you guys. We didn't even talk about that, and you remembered it. It's been like months. Did you even know that you remembered that?
No. Yeah.
Well, you did. I'm proud of you. So we've got log of 100x minus log of the square root of y. All right, so let's deal with this one first. In this log expression, what operation do you see going on between the 100 and the x?
Multiplication.
Yes, which means I need to use which rule? Yes, which means I need to split them up using what operation? Addition. Fantastic. So let's split this up into log 100 plus log of x. Now I'm done with that first term. That's fantastic. Take a look at this second one. Do you see multiplication happening in here?
No.
Nope. Do you see division happening in here?
No.
Nope. But there's one sneaky thing happening in here. What do you see, Luca? The power rule. Yeah, you're absolutely right. So what do I need to do to this first to be able to use the power rule? I need to rewrite it. How should I rewrite it?
Square.
You're on the right track. So it's a square root, and if we want it, Luca, you're on the right track. correct, because if I wanted to use the inverse operation to get rid of that square root, I would square it. You're absolutely right. My goal here is to just rewrite this radical as an exponential. So think about that for a second. Think back in your brain, back in the depths, take a journey. See if you can remember how to write a square root as an exponent. Give me a thumbs up if you remember how to do that. Oh, I saw a couple quick thumbs. Jessica, I saw your thumb. How do I rewrite this square root as an exponential?
Is it minus 2 log?
We are going to have a minus, and there is going to be a 2 involved. So you are on the right track, smart lady. Cam, what do you got for me?
Minus 1/2 log.
Yeah, okay, excellent. I see you did all the steps all together. So you answered like my next 3 questions in a row. Oh, sorry, Rowan. Are you okay? I'll get you a poncho for tomorrow. All right. So what you're telling me, Cam, is that I can rewrite this square root of y as y to the 1/2 power. Go ahead and say, oh. Oh, Nate gave me question face. Nate, are you okay? You're looking pretty fresh with all those stickers. All right. Cool. So, no, I think you've got enough. I think you owe me a sticker now at this point. You got to be handing those out all day, right? Oh, okay. All right, so now what rule am I going to use, ladies and gentlemen? Power. The power rule. Yeah, when I use the power rule, what happens to the exponent? It becomes a what? Coefficient. Coefficient. Excellent math vocabulary from Nolani. So I've got minus 1/2 log y. You guys okay?
Yeah.
Okay, cool.
That's my answer?
Yeah, that whole thing right there is your answer. So we took this single expression and expanded it into a bunch of different logs. Now we're going to do the opposite. We're going to be given a big log expression like that second one, and we're going to have to contract it all together. But before we do that, do you have any questions on the expansion? Go back through the problems we just did, especially the second one. The first one was pretty straightforward. So go back through the steps of that second problem. Make sure you're all clear on what we did, why we did it, how we did it, all the names of all the things. I see your hand, Danny. What's up?
Why is it 1/2 again, and why didn't you just...
That's a fantastic question, Danny. So when we have a square root of a value, we can rewrite the root as an exponent. We did that, I think, in chapter 7. I think that was chapter 7, where we were rewriting radicals with rational exponents. And you recall that the index becomes the denominator and the exponent stays an exponent. So this square root of y becomes y to the 1/2. Then once we have this argument written as an exponent, then we have to use the product rule to make that exponent a coefficient. All right, good question, my lady. Let's do at least one bring it all together problem, contraction problem. Oh, I lost my paper. Oh, there it is. I found it. It's okay. I found it. Don't worry. Okay, let's try this one. Log x minus 2 minus log x. And remember, we're going to contract, so we're going to be using these rules in reverse. Hey, did you know that was going to happen, Luis? Were you just there, ready?
What's up?
Just say yes.
I'm proud of you.
Just say yes to the things I was just saying that you didn't hear.
Yes.
Thank you. I appreciate you. Okay, so take a look here, ladies and gentlemen. We got a trickster amongst us. Take a look here. All right, so I see subtraction in a couple different places. Now let me point out to you where it means we need to do something and where it means we don't need to do anything. So first I see subtraction inside the argument. If we have subtraction inside the argument, do we have any rules about subtraction inside of our argument? No. No, so I'm not going to do anything about the subtraction sign inside this argument. I am, however, interested in this minus sign between the 2 log functions. So if I see a minus sign between the 2 log functions, it means I need to use which rule in reverse, ladies and gentlemen?